Okay, guys, great job with the word search of geometry terms. I put that on there because we have a little bit of geometry stuff that we're doing today. So, yeah. So we are in week 17. That's only because I counted spring break. I feel like it's weird because in my other class it's week 16, but we go to week 19 in here because I counted spring break. Not sure if I should have, but whatever. But anyway, yeah, it is May. What day is today? The 13th, Wednesday. I hope everybody's having a absolute fabulous day because mine's going okay so far, you know. You guys have 3 assignments due this week. One of them is a math mindset. And, put your thought into it. But it's a quick response. I would make sure you get that done first thing right away. And then you've got 2 things. This one is on formulas. It's a great lesson to use our friend Desmos with. Should go really quickly for you. And then you have your circumference scatter plot thing, which we are going to start together today. I'm going to explain how to do it. Hopefully we can all, at least start it together. I think that would be a good idea. So, yeah. Does anybody have any questions or, oops, someone came back, yay! Any questions or concerns on anything? Your grades are fairly up to date. I mean, they were I haven't graded yet this week, but I will today as soon as class is over. And yeah. So do me a favor, keep checking your live sessions. That's been a challenge for me, is just getting those summaries in there. So if you look and you were like, hey, I already did this, send me an email and just let me know, I sent you a summary for this, whatever. What I do is I type your name into my email and then it should pop up, but just in case. Oh, that's okay, Kate. I'm sorry your computer crashed. That's a bummer. All right, guys, first thing, a little bit of review. One of your popular geometry formulas that we're going to talk about is the Pythagorean theorem. The Pythagorean theorem is used with right triangles. Okay, you can only use it with right triangles. Right triangles only. Guys, what's a right triangle? Good. What's a right triangle?
A triangle that has a 90-degree angle.
Oh my gosh, that was awesome. And you guys put it in chat at the same time. Great job, you guys. It's a triangle that has one 90-degree angle. Good job. So the Pythagorean theorem, you can only use with right triangles. It does not work with other triangles. I remember when I was learning this, that's something, it has a baby square. Yeah, I love that. That is something that would always confuse me, is I would try and use the Pythagorean theorem for things that, are not right triangles. So just make sure you do that. Okay. So this is the formula. A squared plus B squared equals C squared. Another word for it is leg squared plus leg squared equals hypotenuse squared. Which side of a triangle do you think is the hypotenuse? Yes! You know what, Malachi? Everybody in my geometry class last year called it the hippopotamus. That's so funny. Hypotenuse. And also, hippopotamus also makes me think of hippocampus, which is like a part of your brain. No? But okay, anyway, the long side of the triangle, right? Yeah. Isn't that interesting? So many correlations in words and stuff. But okay, so the long side of the triangle is the hippopotamus or the hypotenuse. So in this first example, we were missing the hypotenuse. And I'm going to tell you that is kind of a big deal. Okay, so if you have your triangle, if you take away anything from the lesson today, I want it to be that the hypotenuse is not a hippopotamus, but it's the side opposite that 90-degree angle. So here's our 90-degree angle, and if you go across from it, that's the hypotenuse. The other sides are just called legs. They are the legs of the triangle. Okay? So in this next one, in this first example here, we are missing which side? Are we missing a leg or a hypotenuse? We're missing the length. Well, I should say that. So look at that X. That X is missing. And that X is opposite. Yeah, it's the hippo. It sure is. We are missing the hippo because if you go across that 90-degree angle, the X is your hypotenuse. So we are missing the hypotenuse there. So that means we can just follow the Pythagorean theorem exactly how it is. We're going to take the first leg and square it. We're going to add it to the second leg squared, and that's going to equal the hypotenuse squared. Okay, so the first step is to kind of set it up just like that. You take the leg, you square it. What does it mean when you square something? Yes, we did. Now it's a part of the popular geometry formulas, so it's more of a review. So I'm not going to go too much into it, just this slide. Good question. So what does it mean to square? I said swear. Square something. We're not going to talk about swear words. What does it mean to square something? What do? You swear about it. No, I'm just kidding. Like 15 squared. Yeah, you go like that, Malachi. What does it mean if you have like 15 squared? What is that telling you to do? Yeah, very good. It tells you to take 15 times 15. You're right. And that's good to just kind of, remember because it's easy to go 15 times 2. It really is. But okay, now we have set it up in the formula. Now we're going to go to our favorite, can't even spell it, website ever. We're going to go to Desmos because Desmos is just super helpful at this part. Okay, so we're going to go to Desmos and we're going to type it in because the way we do it is we evaluate the 15 squared plus 15 squared, and then we're going to take the square root. And I'll explain that. So first thing we're going to do is we're going to type in 15 squared plus 8 squared. And we're going to hit enter. And we can see that gives us 289 squared. Or not squared, 289. And that is what we get when we evaluated the left side of the Pythagorean theorem. So right now, my Pythagorean theorem is still equal to 12 to x squared. Okay? How am I going to get rid of that squared so I can figure out what x is? Because this is where I'm at right now. I don't really want to know what x squared is. I want to know what x is. What do I have to do so I can get to x? What's the opposite of squaring something? What do you guys think? What's the opposite of squaring something? Crickets. Chirp, chirp, chirp. keep looking at the okay, waiting for more chat. Here, I'll give you this thought. If I know that some number, yeah, thank you, Piper. That's right. Because if I knew some number squared gave me 25, I would say, well, that's 5. And 5 is the square root of it. So we're going to take the square root of that 289. And that'll get us what the side equals, which is 17. Okay, guys, so really the process that you have to do in Desmos is type in 15 squared plus 8 squared, and then square root whatever you get. And then you'll find out that the missing side is 17. Good. Questions on that example? Any questions? Say no if you have no questions. Sorry, I should clarify that. Okay. Do you want to see another example like that one real quick? Yeah, put no if you don't. It's a super fast one. Okay, cool. Thanks, Chase. I had a good one in my head. I had a good one. I'm going to clear all this off. Okay, so for this triangle, same deal. I'm going to even be lazy and use the same side. Okay. So we're going to have this side be 9 and this side be 12. Right? Yes. So we want to do the Pythagorean theorem with 9 and 12 to figure out what our hypotenuse is. So what am I going to square and add together? The legs. I'm going to square the legs. Oh my gosh, that makes me think of Lord of the Rings. What about their legs? They don't need those, right? Just kidding. All you have to do is square the legs and add them together. And technically, it is equal to x squared, but we're not going to worry about that. I'm just going to have you guys focus on what to put into Desmos. Okay? So we're going to go 9 squared plus 12 squared. And you get 225. Then what am I going to do to that 225 to figure out what my missing side is? What do I have to do to that? That's why we're doing another one, right? I have to do one more thing. And the thing I'm going to do, it's my way to cancel. Oh, wait, I wanted to do 25. It's my way to cancel squaring something. What's that thing called that you cancel squaring something? Somebody say it. I know someone knows it. Yes, thanks, Emma. We're going to square root it, right? That's this thing, square root. Okay, so first thing you type in is this. Second thing you type in, and then that gave us 225. Second thing we do is we type in the square root of 225. And that gives us 15. So that tells us that our missing side is 15. Make sense? Good. All right, next one. Now this one's kind of weird because what are we missing here? Are we missing a hypotenuse or are we missing a leg? We're missing a leg, right? If you look across from the 90-degree angle, that's our hypotenuse and that's there. Now there's two ways to think about it, okay? One of them is the algebra way. One of them is the quick, let's enter it into Desmos way. I'm gonna show you both. So technically the algebra way, what we do is we follow the formula. I'll take my first leg and square it, but I don't have a b, so I leave that one alone. And then I take my hypotenuse and square it. Then I'm going to square them and simplify. So what's 6 squared? So we kind of simplify 36, good. What's 100 or 10 squared? Yeah, thanks. That was an epic fail on my part. I did. And then what would I do to solve the equation to get the b by itself? The b squared by itself, rather. What do I have to do to this 36? Not yet. Andrea, you are totally right. That is a step that we have to do, but that comes last. What do I do before I can take the square root? Let's remind you about the other one. In the other one, you had to add them together before you square rooted. Now, in this time, I can't add anything because the 36 is on the other side. So it's the opposite of that. What would I do to get rid of that positive 36, get it away from the b, and put it on the other side? What do you guys think? What's the opposite of that positive 36 there? What do you guys think? Solving an equation. It's like a one-step equation, kind of. Because we want to get that b by itself. So we're going to do the opposite operation of everything around it. So right now, there's a positive 36 in front of it. What's the opposite? Yes, thank you, Scott. Minus 36. Very good. And then b squared is 64. Now we're going to do what Andrea said, and we're going to square root both sides, which tells us b is 8. Now that's a little bit more work. Who would like a way that you could just quickly type into Desmos? Super quick. Nobody? Everybody's okay with algebra goodness there? Okay, cool. Yeah, I need to see you guys are alive in live session. It's boring. Okay, so before we were missing a hypotenuse. Now we're missing a side. So the other way you could do it, if you're missing a leg, you're going to start with your hypotenuse squared. Oh, and we're going to subtract it, the leg squared, the other leg squared, and that equals the missing leg squared. That is the other way you can do it. And then in Desmos, all you have to type in is 10 squared minus 6 squared. 10 squared minus 6 squared gives you 64, and then you take the square root of that 64, which is 8. So that's the other way to do it. Okay, So again, I know, right? It goes a lot faster. So here was our triangle. We had a hypotenuse of 10, a leg of 6, and we were missing the other leg. So the other way, if you're missing a leg, you start with your hypotenuse and square it. You subtract your other leg and square it. And then that's what you type in, 10 squared minus 6 squared. That's 64. And then you take the square root of that 64, which is 8. Yep, you're right. So that's the other way. If you're missing a leg, you start with the hypotenuse and then subtract. If you're not missing the leg, if you're missing the hypotenuse, you add the two legs together. But you always end with the square root. Does that make sense, guys? Tell me. Does? Okay, good. Good. Any questions on that? So we have more formulas to get to. Okay, let's talk about the midpoint. What is a midpoint? What does it do? What does it sound like it does? What does the midpoint do? Or what is a midpoint? If you think of like a set of data, okay, so let's say that you have a bunch of test scores, so 27, 42, 97, yeah, just let's take a small. What would be the midpoint of that data? What's a midpoint? Kind of says it on the screen, my friends. Oh, I don't know. It could be. Oh, yeah. Oh, you're talking about the data. Pfft, Andrea, I'm sorry. Yeah, the middle, right? So the midpoint is the middle. So it's kind of like the average of 2 points, okay? So the point in the middle of 2 points, the midpoint cuts a segment into 2 equal halves. The midpoint formula is this. So all we have to do for the midpoint is we're going to take our x's, add them together and divide by 2. Take our y's, add them together and divide by 2. So what are my x's in point R and S? What are my x's there? And I will remind you that every ordered pair is in the point x, comma, y. So what are my x's that I would add together there? -4 and 3. Very good. So -4 plus 3 divided by 2. And what are my y's that I would add together? 2 and 6. Good job. Okay, then I'm going to do the math. -4 plus 3, what is that? What's -4 plus 3? -1. Yup. Good job. And then 2 is the denominator. And what's 6 plus 2? 8. And then divided by 2? 4. So the middle of this point, if I plotted it on an XY axis, I would go -4, 2. There's R. The middle of that is -1/2, 4. That's the middle. And then the other one is 3, 6. So that would be the middle. Any questions on that? So this is the formula that you're going to need when you do midpoint questions. You're going to add together the x's, divide by 2, add the y's, divide by 2. If you have questions, please put no. That way I know you're still there. Alrighty. Few responses there. I will take it. Okay, the last formula, you guys will love it. It's another Desmos thing. Woohoo! Okay. Desmos. So according to this formula, we take our second x value and subtract our first x value. Square it and then add it to the y's subtracted. So here are my points. What is my second? And I got to follow the formula exactly. What is my second x value according to these points? Which number is my second x value? 3, right. 3 is my second x value. So that goes first. Which one's my first x value? Wouldn't be, it's not 4. What's my -4? That's okay, no problem. And guys, notice how the formula has me subtracting them. Don't get confused and think that that subtraction goes with the number. It's a part of the formula. It's got to be in there. So sometimes you will be subtracting a negative, just like slope. And what's my second y value? Oh, that's okay. What's my second y value? Six. And what's my first y value? 2. Yeah, good. So what I'm going to do is I'm going to go to Desmos and I'm just going to type it in exactly like that. Okay. So I'm going to type in a big square root first, parentheses. If it shows parentheses, you have to type in parentheses. Minus a -4 squared plus 6 minus 2 squared. Hit enter. And then it's going to tell you where to round it. Sometimes it'll say the nearest thousandth. So guys, if I rounded this number to the nearest thousandth, what would that be? If I rounded that to the nearest thousandth, what would my distance of the line segment be? Which is that number? Round it to, okay, if I rounded to the nearest thousandth, how many decimal places would be after the decimal? Yes, Andrea, you're right. It would be 3 places after the decimal. Good. So that means I'm looking at this 2, and the number next to it helps me decide if I bump it up or leave it the same. What would my number be? Same. Yeah, so I would just say my answer is 8.062. If they wanted you to round to the nearest tenth, That's just one decimal point after the zero, after the decimal. So that would be 8.1. So good. That's the distance formula. It's just a matter of writing it down and plugging it on in. Does anybody have any questions on that? What? Where did my slides go? There they are. Good, good, okay. So, friends, I would like you guys to try this one. So we want to find the distance between point A and B. So guys, in order to do that, what am I going to have to do with A and B first? There you go. I muted myself. No. What would I have to do with A and B first before I can find the distance between point A and B? We can't really count it. Unfortunately, it's not very logical. It's not very easy. You can't just go 1, 2, 3, 4, because it's over there. So what do I have to do if I want to use the distance formula? Here's the distance formula. What do I have to do? What am I going to put in the formula? Do, 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 do. The coordinate. Yes, Andrea, good job. We need to know what the coordinates are. So my A coordinate, what would my A coordinate be? 0, 0, good. What about my B coordinate? 6, 3, good. Hello. So I am going to put 6, 3, and 0, 0 in there. And I don't know where a lot of you guys are today, if you're just taking notes or trying to follow along, but let's make sure that we're all participating, just because it takes a really long time if we don't. Okay? Oh no, that is absolutely acceptable. But I'm talking about how you're responding and not anybody else is. So you're awesome. Everybody else is still awesome, but yeah. That's okay, no problem. I'm just greedy. I want all of the attention. All of it. Okay, so go ahead and plug those values into the equation, and then let me know what you think it is. Yeah, the first coordinate is 0, 0. And remember, that's an X and a Y. That's an X and a Y. Oh, no, that's fine. Whoa, I'm getting comfy on my bed there. No sleeping. Somebody's having internet issues. Yeah, 6 and 0. Yeah, those are the X's. Good. So what I'm going to put in the first one is I'm going to go, excuse me, 6 minus 0 squared plus. What am I going to subtract? Yup, it's going to be 3 minus 0 squared. And then we're going to type that exactly into Desmos. So guys, go ahead and type that into Desmos. Let me know what you get. It's 6, 6.7, or 45. Malachi says 45. Oh no. That happens. It's okay. Oh, what did I get? Do you see where you went wrong, Malachi? I wonder if you just forgot to square root. Yep, you just forgot to square root. I don't know, maybe it didn't take it. You know, guys, if you type it in like this, let's say you type it in this way. Yeah. That's okay. Now you know. Did everybody else get 6.7? Okay, good. Good stuff. Okay, please find the midpoint. And it looks like we have the same points on here. We have 0, 0, and we have 6, 3. So we have a line from A to B here. We want to find the midpoint. And here is the midpoint formula. Piper, question? The midpoint is 3? One of them could be 3. No, you know what, Piper? You're thinking real. Basically, you're finding half of X and half of Y. Honestly, that's what we're doing. Because the midpoint tells us that we add the X's together and we add the Y's together. And if one of our X's and Y's is 0, then it is just going to turn into, if I put X in there, it's going to be 6 plus 0. And Y is going to be 3 plus 0. So what's half of 6? What's 6 divided by 2? What do you guys think? Half of 6. And again, we're just plugging in the formula. Are we alive? Did I lose ya? We have the answer already? That's okay. No, I'm just wanting to know. Are we confused? Okay. That helps me to know. Okay. So I did a flyby, went too fast. So guys, this is the midpoint formula, correct? Right here. Okay. No problem. And I'm so glad that you say something. I don't want to lose you. So our A point is 0, 0. Our B point is 6, 3. According to the formula tells me I have to take the x's, add them together, and divide by 2. Right. Yep. So if I want 0 plus 6 and divide by 2, 0 plus 6 is 6. 6 divided by 2 is 3. For my x value, and for my y value, I take the y's and add them together and divide by 2. And what is 3 divided by 2? 1.5, yeah. So my midpoint is 3, 1.5. This is the midpoint on the line. Yep, so number 2 would be the answer. Yeah, so you're just writing the formula down, plugging in your values, and then just simplifying. What I was saying before, someone said that the answer was 3. No problem. Someone said the answer was 3. I was saying, since you're starting at 0, it's like you're just taking half of your x and half of your y. It's just one of those weird problems, but I think I lost people on that, so I apologize. So yes, it's just plugging stuff into a formula and then going from there. Okay, questions? Questions on geometry formulas? Please say no if you have no questions. Okay, if you're feeling unsure and you want some help, let me know. I'm here to help you. Okay, let's talk about that other assignment. The other assignment is called a circumference scatter plot. Okay, and what it requires you to do is it requires you to find 10 circular objects around your house. So if you guys look at my camera, and I'll stop sharing for a second so you can see my camera bigger there. But if you look like here, I brought a water bottle. Okay, so that's one of my 10 objects. Okay, so anything circular would do. I even have a gum container, and the top really isn't circular, but the bottom is. So I could use the bottom. So we're basically just concerned about circles. That's it. Okay, and according to this assignment, the first thing you're going to do is you're going to start a spreadsheet. And some people knew where to go for a spreadsheet, but in case you don't, okay, if this is your email, to get to your Google Drive or Google Sheets, you're going to click on this little button next to your login information there. When you click here on this grid, it brings up all your Google apps you can go to, and you're going to click on Sheets. And then you're going to click on a blank spreadsheet. Okay, and the first thing I would do is I would title it. Jen's circumference scatter plot. Okay, and then on top, I like to make the whole row bold and a little bit bigger for the title or for the heading of each. That's what I do. So the first one I'll type in is object. Then you are going to measure, and I'm going to look exactly in the assignment for how to word it. It tells you exactly how to set up your chart in here. It's going to be diameter, circumference, and circumference divided by diameter. So diameter in centimeters, circumference in centimeters, and it was circumference divided by diameter, also in centimeters. And we're going to have to widen our columns, so you guys know you bring your mouse in between the letters at the top. You can kind of click on there and hold it to drag it over and make each column a little bigger. Sometimes you have to click off of it. Okay. And then you're going to think of your 10 objects. So I might say gum, container, water, bottle, I don't know, bowl. What else is circular? Lotion, bottle. I wouldn't pick a sphere or anything like that. I would make sure it stays top of can of soup. So you need to come up with 10 objects. Makes sense so far? Oh no, that's right. We've been through this. Oh my gosh. Well, you could have a can of soup, can of sauce, you know, top of cup. There's lots of options. Spout of juice. Top of pitcher. There you go. Yeah, a straw, that would be kind of hard to measure, but it is in centimeters, so it does work. Okay, does everybody know how to get into Google Sheets and make a scatter plot? Or not a scatter plot, a piece of data like this? Does everybody know? Okay. So your next step is you're going to take either a tape measure, because tape measures are flexible, or a piece of string. I have a cloth belt here. That's what I have. I'm going to stop sharing for a second. Where did my menu go? There it is. So I have a cloth belt here. And what you're going to do is you're going to take your circular figure, whatever part you want to measure, and you need the diameter first. So that is just the distance from, ooh, my bottle's leaking. No. Makes sense, but okay. So from one side of your circle to the other side, and it's got to go through the middle of your circle. Okay, so you're going to either just take your ruler and line it up there and read the number that it hits on the centimeters side. You can also take your flexible object and put it up there and measure it, and then just lay it up next to the ruler. If you don't have a ruler, you could always look up a ruler online. I know there's different images of like a real life-size ruler, and you can measure it that way. Okay, so you need the diameter in centimeters. Then the next step is you're going to go around the figure with your cloth object there. Okay, go around, and then you're going to measure the circumference of your circle. So you would just lay this section on a ruler, and that would say the circumference measurement. Okay, so you need the diameter, distance across the circle, circumference, distance around the circle. And it's just a matter of reading the centimeter measurement. Does that make sense, you guys? Distance across, distance around. And then the last part is to divide. You're going to divide according to the chart, it says circumference divided by diameter. There are other things to do on that assignment. Talks about how to make a scatter plot and all of that. I will create a separate video just to demonstrate that part, and I'll post it right on Moodle. I'll do that today. But for now, for today, what I want you to do is get your geometry formulas assignment done, and then set up your spreadsheet. And where's my chat menu? There it is. Set up your spreadsheet and then get your measurements done. Okay? Any questions? There are instructions right on the Moodle page. If you want to just do it, get it done, go ahead. But otherwise, I will put a video out today about how to do that. Does that make sense? Just because we're right at time here.